right, good evening. So, thanks for having me here first in Tokyo, Japan, and Tachigawa. So, I really love this place and all. So my topic is basically bringing 3D content to your iOS applications. So, if you attend to the morning sessions in the Mikila sessions and also the Rio sessions, so you may heard a lot of terms and creating a 3D content and bringing those things into the Vision OS, and especially using tabletop API, and also the create 3D content using AI models. So, but in my sessions, I'm going to talk about little behind the scenes. Let's say, as a developer, how you identify these things and how you create this kind of a 3D stuff. So, as Tim said, like my name is Kosala, and I'm from Sri Lanka. So, I'm into iOS development well over a decade now. And also, apart from the iOS development, I'm also doing 3D content development. That's why I'm into this kind of different topics. So in my session, I'm going to talk about how to create the 3D assets, or how to prepare the 3D assets for your iOS applications, or maybe the Vision OS applications, or maybe AR applications, and also how to bring those things into the iOS applications. Right, so first, let's talk about how to create or how to prepare your 3D assets. The first thing, before we jump into creations, we need to know about what are the barriers as a developers we are faced in when we are creating a 3D content. So especially the 3D software, it's something different which we are not regularly use. So basically, as a developers, we are mostly use Xcode, but not the 3D softwares. So for the creating 3D content, we need to have a different set of skills, and also it's a very time-consuming process. So if you're attending on the Rio's presentations, so you may already heard about from him as well. So it will be a lot of time-consuming process to create a 3D object. And also, some of the softwares is not really free, and also you need to have a set of different hardware to create a proper 3D object. So, and not only that, so to create a proper 3D things, so you also need to know about some of the 3D concepts. So that's the other big stuff when we are facing to the integrating this, like the bringing 3D content into the mobile applications, and also maybe the Vision OS applications. Something like geometries, polygons, the file format. You might heard about USDC a lot of times, and also the FBX, and also the shaders, something like materials, lighting, sort of a physics, and the particles. But I'm not going to talk about all those things, but I'm going to talk about some of the key features you should know about before you creating your 3D component. The first thing is you need to understand, let's say, if you're creating any kind of 3D object, you need to understand how these things are built, the fundamental building blocks of the 3D component. The first thing is we can categorize as a geometry. So under geometries, everything's built from the vertices. So vertices, lines, polygons, and the mesh are the fundamental component of the 3D object. So then the textures, so under the textures, we need to understand how this UV mapping, materials, and the lighting work. So then also we need to have a sort of understanding about this file format, especially if you're downloading the component from the internet. So you can see in the next couple of minutes, so how we download and craft these things into the different file format. Let's say FBX and the USDC. Also you need to learn different tool set like Reality Composer Pro and Reality Converter, as well as the RealityKit. So as a developer, you can also create 3D models using 3D softwares like Blender, 3D Max, or Maya. But also you can use third-party resources to download from the internet. So there are a lot of marketplace available, so you can download this 3D component from the internet. But I'll explain you what would be the issues you're going to face if you're downloading things from the internet. Also, you can use if you have a existing 3D object, let's say existing models, some sort of like items in the real world, and you also wanted to bring these things into the your applications, you can use Apple's photogrammetry API, which is I'm going to talk about more in next slide. And also you can use neural radiance fields as well. So that's another technology that we are going to use to create a 3D model. Also, and as Rio said, you can use generated AI models using AI things. In 2025, you know everything is come up with the AI. So definitely you can use the AI models as well. So here's the Apple's way to do this. So they wanted to have developers creating more 3D applications, more 3D content, especially for the Vision OS and the Vision Pro devices. Because Apple are really pushing the Vision OS devices, so they are creating new APIs and also the new content for the Vision devices. But the thing is, still developers are little lag behind to create the 3D applications because of this 3D content. So that's why they introduced the new RealityKit and also the photogrammetry APIs to developers to integrate their to make the development pipeline much more easier to integrate with the RealityKit. So the first major benefit is having this photogrammetry API is one is it's out of the box work with the iOS and the macOS, and also if you have like Apple Silicon. So everybody has right now. So I guess, so then it will be much more easier to create through the command line tools as well. And also it's seamlessly integrate with the USDC workflows, and also it's like ultimately making super seamless integration with the 3D creation. So with the photogrammetry API, so you can you can get a set of photos around the object and sides of the object. So then you can import it into the macOS application. So it's pretty much easy. So all you have to do is like you have to pick the folder location of the photos, and then photogrammetry API automatically understand the image and running through the ML workflow, and it will create a nice 3D model. So I'll show you some of the thing what I have done with this one. So in this example, I only captured 30 photos of this model, right? There's no more than that. It's because these photos I took around like evening with less lights and no any proper setups, right? But then I'll be able to create this type of a model, right? With the 30 photos. But let's say if you wanted to use more detailed object, so then you can use more photos with the proper lighting, and also if you can use the round table or something to get a proper photos, you can instantly get that type of a 3D object. But the thing is, Apple not limiting that photogrammetry API from the macOS. With iOS 17, they introduced new API called Object Capturing API, which is work on iOS 17 plus. And without macOS, without taking a photos, set of photos, you can now real-time convert these things into the 3D object using this Object Capturing API. But the thing is, so using Object Capturing API, you have to be aware about little bit more about the material that you are working on, especially if your real-world object has a glass or the glossy materials or maybe the metal kind of a materials, then you won't be able to get the proper output just because of the LiDAR sensors. That's how the LiDAR sensors work. When the LiDAR sensors instantly send the light beams, and when it's reflected back, then only the 3D mesh work. But if you use metal kind of a material, it won't work well. But the other kind of materials, you can create the seamless way. So this is the couple of chairs in my office I create. But if you see, the one chair is not real. So the other chairs are the fixed one, but the other one is not real. Because I capture all these things using Object Capture API, and I export it into the USDG file. But it's not really perfect, but because the capturing these things will take time, but not really taking time than you are creating from the scratch. But the thing is, so you can create this one, and then you can definitely import it into the 3D software and make it perfect and make it fine-tuned more. But the thing is, when you download something from the internet, sometimes when you try to convert this one, so if you ever download some kind of a 3D object to your Vision OS application or maybe AR applications, so sometimes when you try to convert it, so you might end up with this kind of a grayish and the gray color object. The reason because of this one, the textures. Because when you're downloading the object, especially the file format, you won't be able to get embedded textures. So instead of that, you will get this kind of a different texture files. So as a developer, you might be wondering about what kind of things this one. So how do I manage this? Right? So the main thing is you need to texture embedded to the 3D objects. So we call that one basically texture baking. To bake the textures, you might need to use a 3D software. So in this case, when you're downloading this 3D object, so you will get basically you need to have a base map and the normal map and the displacement maps. So these kind of maps are really important to see the detail of the 3D object. So to do the texture embedding, or the material, like the material and the texture baking, you can use the shader graph in any kind of a 3D software. So in this case, I use the Blender shading graph. So embedding the 3D, like the materials and the texture baking is important. And also use the correct material maps, because different 3D softwares rendering the materials in different way. So the Reality Composer Pro use Material X, but the other software use different kind of materials. So then you really need to careful about the transforming these file format, the interchange in these file format between the different softwares. So after fixing that one, you will be able to get all the materials to the 3D object. And also, there are two key facts you really need to pay attention on this one. When you are creating something on the 3D applications, all the 3D applications use, well, like most of the 3D applications use the different perspectives. Especially if you use the general 3D softwares, the C-axis stay in the vertical axis, and the Apple side, the Y-axis stay in the vertical side. So all you need to do is you need to change these axes before you export this into the export, and before you import into the Xcode or the Reality Composer. So that's really important, because these perspectives are, otherwise you won't see this kind of a reflected object rendering in your application. And also, there's another things called origin point. So that's also very important, because when you're putting something on the canvas, there's a 0, coordination system. So when you're putting somewhere in your origin point, after you're importing and after you're rendering it into the Vision OS or maybe the AR application or the iOS application, you won't be able to see the 3D component in the correct position if you're not changing the origin position. So that's really has to be set before you export it into the applications. And also, if you are exporting something from the 3D software, so you can see, so here I use the Blender, but in other softwares, it's also there. So you have to set which axis you need to put as a up, and also which axis you wanted to see as a forward. And also, you need to embed the texture and the materials. Okay, so after you creating these things, so now you know, so you need to understand the materials and textures are really important. Textures is playing the big role in the 3D models, because if you really don't have the correct textures and the correct materials, your 3D component not look as intended to see. So if you are creating these things, let's see how to embed these things and the export. So all you need to do is, whatever the file format you download, you can use the Reality Converter tool from the Apple. So then you will be able to embed all the physics, lights, and everything and export it into the USDC format. So here's the workflow. All you need to do is, let's say, create the 3D content, maybe using photogrammetry, maybe asking your friend to create that one, or maybe using AI models, or maybe creating. Somehow you need to create the 3D models. Then you need to embed the textures and the materials. Then you need to use the Reality Converter and convert into the USDC. And then we have to use either Scene Kit or the RealityKit. Okay, so the Scene Kit and the RealityKits are important. Let's say when you're bringing into the iOS, so the RealityKit, it's the newest API Apple introduced, which is introduced from the with the Vision OS. But now with the iOS 18, you can use the RealityKit API in iOS 18 as well. So that's really important because if you wanted to backward compatibility, then definitely you have to use the Scene Kit or the AR kit. If you wanted to use the Apple newest, like the most SwiftUI full, like the SwiftUI style code blocks, then you have to stick to the RealityKit, right? So then let's see how to do this. Yeah, this is the key things. So let's say Scene Kit's used for the 3D games and apps with the backward compatibility, but RealityKit is the next version of the AR kit, and Apple is continues to integrate the more RealityKit features into the iOS. Hopefully with iOS 19, they will provide more APIs. Like still, there's no hand tracking and there's no sort of a Vision OS only support features in RealityKit iOS versions, but in a iOS 19 or future, we will get that kind of a features as well. So also, you can use the RealityKit with the code blocks without any 3D content, without any 3D softwares like this. So simple mesh or the custom component, but not any complex object. To have a complex object, you will definitely have to design the 3D. But here's the textures. I guess you already seen these kind of similar code blocks from the Rio's presentations as well. So I create simple PBR material, the physics-based material. So this is how it looks like when you create it and embed it through the codes. Let's say if you want more control, so definitely you have to use the code blocks instead of everything from the 3D softwares. And also, you can use the materials through the code blocks. There are three materials. One is the simple material, and the other one is unit-based materials, and also other one is the physical-based material or the PBR. PBR is the most widely used material systems, so you can definitely see a lot of characteristic specifically belongs to the PBR material system. Also, simply you can get the load the reality view into the iOS. This is not Vision OS, this is iOS, right? So simply you can use the Vision OS framework in iOS as well. But the thing is, you need to check whether your application running on the iOS 18 or not, right? It supports all the sync and the wait as well. And also, if you wanted to do changes and all the rotations and everything, all you need to do is like the reality view camera controls and adding it into the orbit. But let's say if you use the AR kit or the Scene Kit, you have to write down all the gestures and everything. But with the reality controller controls, it's just a one-line thing. So this is how it works with this thing. So for your iOS applications, you can get the reality view, the 3D content like this. And also, other particles and everything is there. So you can use all the particles. You can create these things from the code base, like the tools as well, and also the code base. So in the code base, you have like more control. Also, you know, like as a developer, we really wanted to use like the controllability, like the more control on our side. So at that point, you can use the codes. And also the best thing is, in the RealityKit, you can have some of the things from the Reality Weave, like already baked 3D content, and injected it with the RealityKit codes. So let's say you have like the 3D set of chairs and all those things. You need to change some of the material of the different part. So then you can do through the code. So that's the beauty of the RealityKit. And also, you can use the particles like this. And yeah, and the next best thing is in the Reality Weave, the gestures. Right? You can use the gestures, but not the spatial gestures. Spatial gestures only support on Vision OS. If your application running on the Vision OS, then only it's support these gestures as well. And also, to enable the AR view, you really don't want to have like the AR, like the UI representable wrappers or anything, and the AR kit imports or anything. You just have to have a camera and the spatial tracking enable, and also the camera permission. That's it. So once you enable the camera, and also the entity systems is work here as well. So there's no need to change anything. So changing minimum code, your existing applications run on different platforms like the AR. Let's say you can make a iOS applications. If you wanted to show the same 3D component with the AR feature, you can just enable a couple of lines and port it into the AR version. So that's the beauty of that one. So here's the same demo I put in this case. I put that Thanos near to the conference one. Right. So that's all from my case. So let's wrap the thing. So I guess this all interconnected to the today's other sessions. The 3 sessions we had already in the morning. Tabletop one and the AI generated one, and also the hand tracking with the vision. But all you need to do is you need to understand these kind of 3D concepts in order to create the performance rich and also more contextual rich applications. You need to understand these kind of fundamental 3D concepts in order to create that kind of things. So once again, I guess you had something. And thanks for having me. If you have anything, just I'll be there so you can ask anything. All right, thank you.